All right. Good afternoon, all of those that are attending from the North Carolina GIS conference. This session of the vendor demo. My name is Rick Wallace with NV5 Geospatial, powered by Quantum Spatial. Most of you know me from Quantum Spatial. We have a marketing name change, if you will, to NV5 Geospatial. We are now owned by NV5. And but our legal entity name remains Quantum Spatial, and we are still the same company, just have a larger brand. And that's what I'm going to talk about with you today in our presentation called "What Can UAS Do for You?" It's really just about a new set of services and capabilities that Quantum Spatial has now grown in its capabilities, and we're very excited about this new capability. Next slide. All right. So again, you see myself, Rick Wallace. I know most of you who would be attending this, and as you know, I have 30 years of experience in technology solutions. Part of that in the IT industry, and now the most recent 10 plus years in the geospatial industry. With me today is Kurt Cathall, who's our UAV operations manager, and Lucas Frazier, who's our subject matter expert. Lucas will be driving most of the presentation today, and but I've got a couple more things I just want to tell you about our transition to NV5 Geospatial, a little background about who we are and the breadth of services, and then I'll turn it over to the more exciting capabilities of UAS, which I personally term as unmanned aerial services versus some of the other vernacular that's used out there, because I see it as a suite of services versus just a vehicle or a drone or a sensor or what have you that can be utilized within that confines. All right, next slide. So again, NV5 Geospatial has a large footprint. We're actually in 3 countries, but primarily here in the US. We service federal government agencies, state and local government, as well as private industry. Again, our centers of excellence are the locations that you see on the map there. We're headquartered out of St. Petersburg, Florida. NV5 is actually headquartered in Hollywood, Florida. Next slide. So a little bit about who we are. Again, one of the largest geospatial providers in the US. We have a tremendous footprint of not only our facilities and resources and people, but we also annually do work in all 50 states. So that's pretty good coverage when you think about the breadth and depth of our capabilities. So whether it's fixed wing, rotary wing, terrestrial LiDAR, unmanned aerial solutions or services, as I call it, mobile LiDAR, topographic LiDAR, multispectral imagery, hyperspectral, thermal, and we also stand up a tremendous enterprise GIS services group as well. So we have the ability to not only acquire the data, process it, analyze it, and provide solutions and capabilities for varying applications across our client base. Next slide. Again, core capabilities, we've already talked a little bit about that, whether it's mobile, whether it's helicopter, fixed wing, LiDAR, topobathy, ortho imagery. These are the types of capabilities and solutions that we bring to the table. Kurt, I don't know if you want to take the introduction of yourself a little bit and then turn it over to Lucas.
Yeah, sure. Yeah, as you'd mentioned before, you know, Quantum Spatial is now part of NV5. Myself, I started a company called SkyScene that was predominantly data acquisition via UAS platform. And through that, our company was acquired in 2017 by NV5. And so NV5 pretty much does all engineering, heavy surveying background. The combination of that has really allowed our group to grow and kind of connect the dots, so to speak. And then with the addition of quantum spatial, it's been quite the recipe. So as far as solutions and services go, we have quite the team now. And from there, as you're going to see here in this presentation, being led by Lucas, it's going to give you guys a really good, I guess, overview of just the variety of different solutions that we have in the GIS and the geospatial world. So feel free to chime in and ask questions, because there may be things that may come up and go pretty quickly. So feel free to chime in there. And I'll hand it over to Lucas if that's good with you, Rick.
Absolutely.
Yeah, thanks, guys. As you mentioned, Rick's going to be monitoring the questions, so if something comes up, feel free to jump in. Just a quick review of our services. I'm going to go over these services, and I'm going to go through some sample projects that we did, kind of show you what we're turning out on a daily basis. So we have some platforms. We have an M600 Pro, which is pictured here with our Regal VUX1 Lidar system on it. And, we really firmly believe that's the best system that you can put on a UAV right now. So the data sets that we're getting out of that VUX1 are, really impressive. And we also have a FreeFly, formerly known as BFD system. So for those, clients who need something that was made in the USA, for various reasons, we can accommodate that as well. And we've had plenty of successful missions in restricted airspaces, just communicating. Our pilots are great communicating with local airports and with the FAA to get whatever waivers we need or we can possibly get to get the job done. So let me just go over a couple project examples here. The first one I'm going to quickly review is a DOT accuracy test that we did in Oklahoma. So I know that's a lot of you, maybe some of you have been burned in the past by the accuracy of UAS data sets. So maybe some guy with a drone said he could go out there and get you 2 centimeter accuracy, and then it didn't really pan out. So we really wanted to perform this test to compare our data against data that's being collected by both helicopters and by planes, manned aircraft. And as you can see here, we were able to get over 120 points per square meter, which is very dense. And that's that's a pretty standard density for us. It wasn't really a special survey in terms of trying to get density. We can go a lot higher than that if we have to. But the big number here is the 400s RMSC on hard surfaces, that really compares well with the helicopter and the manned aircraft. So the UAV is just a platform. It's the same scanner that could be, mounted on a helicopter or something else. So we're really happy with the accuracy we've been getting off this. And now we kind of have some data to back it up. Just one more quick. Yep.
Lucas, as we talked about, I'm going to interrupt you as we go.
Right.
First question I have on the chat session is, do you use automated flight planning software?
Yes. So we do our flight planning with UGCS, and all of our flight lines are pre-programmed in there. We load in a local DEM for terrain following so that we're getting a consistent offset from the ground.
Excellent.
Great. So yeah, finally, we have an image up there. You can see our ortho imagery and our LiDAR, even though collected at different times, they're still lining up perfectly. We're not having any issues with that. And just so that everyone knows, we always work with local surveyors to collect our ground control and our check shots. And we follow all the, the national specifications for accuracy testing, whatnot. So let me go over some asset inventory stuff. Part of our, we do a lot of mapping, but we also do, oblique imagery. We're able to really get a high definition on, power poles, for example, for a lot of power line companies that would traditionally have to send somebody up. It's very dangerous and expensive to send somebody up to do all this. We can now come in with one of our really high resolution cameras, still stay a good distance away from the line, but capture imagery like this where you can read the barcode. You can make sure that the bolts are tightened. So that's really a big thing for them, just kind of improving safety and efficiency. And kind of continuing on that safety route, utility markout. So obviously somebody has to go into the road to locate all these underground utilities and to spray paint them. But it would also, have traditionally been another couple days to send somebody, a surveyor, in the road to mark out all this with RTK, virtual station, or something like that. But now we can go in, and with our high resolution imagery, we can pick up all of those paint markings, all of those features, valves on the ground that are hard to see, and we can map them out and turn them into, a microstation or civil 3D drawing. And yeah, we have some road cracks here. This has been another, interest of some of our clients, is being able to detail road cracks, flying over still at a fairly high altitude, around 400 feet. So we're covering a lot of ground pretty quickly, but the detail is enough that you can really take inventory of road quality. Finally, we have some thermal imagery. You're able to detect hot spots. We do a lot of solar fields and buildings, and also, utilities, just to try to find anomalies and other things that pops out with the thermal imagery. I have a quick video here. This is a survey that we did where we combined our aerial LiDAR with terrestrial LiDAR. So 2 data sets were collected independently and then tied together using ground control. And we actually put those data sets into Revit and generated this 3D model. So this was for historical preservation. So the building needed to be knocked down, but then they wanted to rebuild it exactly the same, to the same dimensions as it was previously. So instead of, taking it apart piece by piece and having to put it all back together, now they have this complete and accurate model that they can use to reconstruct the building. And it's nice because it's really tough, to scan everything with terrestrial LiDAR in these areas. So being able to kind of combine the 2 data sets and use the aerial to fill in the gaps was really a huge win for us here. Skip ahead to the next one. So this project, we did some street mapping. So it was close to an airport, and our pilots had to communicate with that airport and able to get authorization to fly here. And then, we collected a LiDAR point cloud. This is a very high density one, a lot, I'm talking a couple hundred points per square meter. And we did this just in order to be able to collect break lines. So this data set is huge, 300, 400 points per square meter is just too much data for most clients to be able to handle. There's a lot of useful information in here, but it's just not practical for a lot of people to use it. So I'll kind of highlight here how we filter down to ground, and then we take that really high density data set and we turn it into something like this. So just a collection of break lines and points. You can see we have road cross sections in order to pick up the crown and the shape of the road perfectly. And then we just have a 5-foot grid for the rest of the project. So even though we have, all of the data in our point cloud, it's just not realistic for a lot of people to be able to use that, whether it's, a microstation, DTM, or a civil 3D surface file. We really have to filter down to much smaller file sizes while also maintaining the high level of accuracy that they would require for this project. So you can see we're even picking up, the ramps and all the retaining walls on the properties. And like I said, top of curb, bottom of curb, lip of gutter. And here's just a picture. Here's a quick cross section of the road. You can see we're not really losing any detail in terms of the crown, and then there's the curbs. So let me skip ahead to the final deliverable. This client wanted a civil 3D surface, so you can see how we took really high density, a lot of data, and we thinned it down to just what they needed. And we did hide boundaries around all the houses and added in our spot elevations and contour labels.
Lucas, another question just came in asking what's the typical flight altitude of the LiDAR sensor?
So we generally fly around 122 meters, or that's just over 400 feet with this scanner. We will occasionally fly lower if we're really worried about penetrating some super dense vegetation, or if there's a requirement to get really high accuracy data. But, you know, we find even when we're flying that high, we're still able to do this kind of break line mapping. We're still getting detail on curbs and other important features.
Hey, Lucas, this is just, I heard you say over 400. I know you meant to say just under 400. So you're talking about like the 360 feet mark. Is that what that kind of translates to, the 120 meters?
Yeah, sorry, I should have done that conversion. I work mostly in meters. I know you're right. We got to stay under 400 feet.
Okay.
Yeah, no, that was my bad. But yeah, I think it's around 120 meters. We're under that 400 foot thing. Thanks for pointing that out, Kurt.
Yeah.
That.
Another question that came in, do we fly the UASs ourselves or have a team of pilots? Also, what type of entities, organizations are the majority of our clients thus far?
Right, so we definitely have a team of pilots. They do all the flying and they handle the waivers and the flight planning and all that. And what kind of clients? I mean, they range from departments of transportation, private sector, utility clients, engineering firms, environmental firms. We've done some, you know, vernal pool studies, that kind of thing.
Right.
It's really.
We've also had some local municipal firms, entities looking for things like preservation of building fascia for historical buildings and so forth, and those types of things that have driven some really unique applications.
Right. So skipping ahead a little bit here. This is the same project that I was showing you earlier in some of the asset identification slides. So you can see we have the utility market on the road, and it's just an example of how 3 different data sets come together. So we have our 2D planimetrics, that's what you're seeing here. So all of the paint striping, all of those, you know, 2D features that you would see kind of from a top-down orthomosaic image. And then you combine that with our utility markout. So this is, you know, the painting on the road was done by a local contractor, and then we went in and did all of the markout from our imagery to create this map. And then finally, the surface file was generated from our Lidar, and we brought those 3 data sets together to create the final drawing here. So the final one's a bit messy, having all those data sets in there, but you can really see how the technology, the Lidar and the photogrammetry kind of complement each other and allow us to just extract a ton of detail from these areas.
That's excellent. Another question, how large of an area can we cover in one flight?
In one single flight?
Yeah, a lift, if you will.
Right. So with our M600 Pro, we can fly, I think, around 2 miles. Kurt, what are we going to be able to cover with the free fly? That thing can fly for over an hour. So
per flight right now, I mean, depending on the actual scope. So depending on the density that's required. But let's just assume the lowest density that we could really fly, based on us needing to stay, you know, below the 400 foot above ground level. You're looking at a few hundred, 200 to 300 acres at a lower density, and the imagery is pretty close to that as well. So on a bigger picture, you know, in operations out in the field, you have your charging station, you have multiple batteries. So when you do fly, you know, you land, and then the drone is back up in the air. So you know, you're looking at a few thousand acres that you can get in a day with the platforms that we're using, and that's around an inch pixel resolution, or an 1 inch ground sampling distance, so pretty high resolution. And then approximately 50 points per square meter is what we're getting with these newer platforms.
Okay. And we are continually investing in latest technology capabilities that will expand our our flight time, and therefore our coverage.
Mhm.
And one thing to add to that, I know Lucas brought up our M600. We use DJI M600s for a lot of applications. For our larger projects, we use some American-made drones or UASs, and those are the ones I was referring to. The M600, you're about the 100 to 150 acre mark, depending on what the specs are. So per flight. So kind of a big difference with our heavier lift platforms versus the M600s. Just to clarify that.
Sounds good.
Thanks, Kurt. So finally, I'm just going to cover this inundation study we did for the city of Oakdale in California. So they have some settling ponds and some berms up here at the top of the city, and they were worried that what would happen if there was some seismic activity or if one of the berms collapsed. And we just kind of wanted to illustrate a typical turnaround time. So this project is kind of made a rain for us, not our largest, but definitely not our smallest project. And so around from when we received the notice to proceed approval to do this project, it was about 1 week till we were on site collecting, 1 day field time collection, about 1 week to process it. And you can see that, from the notice to proceed to our delivery of the DEM for the study, it was less than 4 weeks. So having up-to-date information like this was really critical for them, because I know sometimes there's public Lidar available at a slightly lower density, but just it can be out of date by the time it gets in your hands. So for them, having an affordable and accurate way to get some really up-to-date Lidar for a DEM was crucial for this project.
Another quick question, how many ground control points to be used?
For a project like this? So it depends. This project didn't have any imagery in it. So for our imagery, we have photo ID points, ground control points spread throughout the entire image that are used to tie it down. But for the Lidar, it's just one. It's the ground control point that is tied to the base station. So that's the only control point, and then the rest are all check shots. So there would have been several hundred check shots spread out throughout this site in order to actually do the accuracy calculation. And those are all independent. So they're not used to tie down the Lidar in any way. They're all independently collected and used to just verify the accuracy of the elevation. And they're quick because they're not panels or anything that are being set. They're just vertical check shots on hard surfaces. So we can collect a large number of them fairly quickly and then, have enough to do like a statistically significant accuracy calculation.
Hey, Lucas, I just wanted to add one more thing to that regarding that question with how much ground control is used. Not all drones, as we know, are the same. There's drones that have IMU and high precision GPS on board, and that is a huge factor in the quantity of control you're going to use. So if you take a let's say a DJI Phantom with standalone GPS off the shelf, and you're trying to get an accurate data set with that, the cost and the amount of ground control you're going to use to actually, get close to the accuracy that you're getting with something that has IMU data, that cost itself doesn't make it worth it using a UAS. Now, smaller projects, if you're looking at a project 2 to 20 acres, you can put 20 ground control points on there or aerial targets on there, and you can get your accuracies pretty decent. But when you start getting the larger projects, to get that accuracy, you're going to have to litter it with ground control. You're basically going to have to do a grid to keep those accuracies very tight. So having I guess I'm reiterating the importance to having the right equipment on board because throughout the entirety of the project, there's a big cost savings there.
Yeah, that's a great point, Kurt. So we do, PPK post-processing for all of our trajectories, whether it's Lidar or imagery. And, the ability to do direct georeferencing like that really, cuts down on the number of ground control points that would be needed otherwise.
Got an interesting technology question here, Lucas. Is there any technology available to provide stream channel morphology from UAS?
So stream channel morphology. So we can, with our Lidar system, we can do a DEM, just an elevation model and then an imagery. And then, we can get our ortho imagery in there too. But I'm not exactly sure. That would be a question for our engineering department, because we generally provide these data sets and then we turn that over to them and they do all the study. So this study was done by another department in MV5, the one on the previous slide, but that's, if you have, questions about that, you can definitely reach out and we can, get you connected with the right person to kind of talk about that.
Yeah,
Yeah,
and I think a spherical imagery capability, which we have, if I remember correctly, can certainly look at conditions of stream channels and so forth as an application.
Right.
yeah, those are really good points. Now, with as far as the sensors and capability, say for example, if you are assessing a stream or the changes that take place, the data sets, we have certain clients that will overlay data sets and monitor change that way. But obviously water with Lidar, you're going to run into a roadblock there with not being able to get data underneath the water. So we also have bathymetric sensors as well. So we can actually fly with Lidar, get all the ground topography through, vegetation, bare earth, and then, you fly the bathymetric and you can get accurate data points underneath the water. And then whoever's, like Lucas was saying, whoever's using that data, they have the right tools in their hand now. So as far as the assessment goes, that capability is there. We, as Lucas was saying, we just don't do it ourselves.
Mm-hmm.
Me or Lucas, our other departments do, but we can't speak on that.
Yeah. Our group in Oregon certainly does.
Mm-hmm.
And then one last question so far. I know we're getting close to the end here. How do you deal with strict drone surveillance laws? Like in North Carolina, you can't take images over private property without permission. So that's kind of down in the policies and rules and regulations arena.
Yeah, I can talk on this, Lucas, if you'd like.
Yeah.
So there's due diligence on these projects. There is a process depending on how sensitive the property is. In most areas, there's that reasonable expectation of privacy where you can't be hovering down next to someone's window. But when we're in the utility space, there are exemptions to that rule, because that's no different than if you have a lineman on a utility line, 200 feet up in the air. That's the same field of view that lineman has as the UAS. So there are exceptions within there, but the big key is notifications prior. That's the biggest thing, is the awareness. You'd be surprised the approach of surrounding folks that would go be from irritated to acceptable and not throwing a fit if you just take the time to notify and make them aware. No one likes being surprised, so there's that factor in there. But that's really the biggest. As there's a lot of different variables, a lot of different scenarios that you can dissect, but the meat and potatoes of it is notifications prior to flight in the surrounding areas or where you're going to be. So that's
All right.
pretty much
it. We're wrapping up. Any last comments, Lucas?
No, I just wanted to show we have, really quick, I know we're running out of time. We have a portal that we can use to host all of these data sets. So whether it's the imagery, you can do distance measurements. All you need is, a web browser, and we can even put our full density point clouds up there, colorize them, once again, distance measurements, that kind of thing. And this image comparison slider, so images collected at different dates at different times for construction management, we can have that all loaded in there so you can see on exactly what date where the progress was. And then I'll just leave this up here. This is just some of our spherical panoramic imagery. well, if we want to go through any final questions.
Yeah, I don't see any at this moment, but great job, Lucas, Kurt. Appreciate you coming in to this session for what UAS can do for you. Guys have any questions, those that attended, anything further, always feel free to reach out to myself, Rick Wallace, here in North Carolina, and look forward to spending more time in the near future actually seeing people in person. Again, thank you for all who attended. And we got one last quick question. Have you ever worked with integrating satellite data sets?
Yeah, so satellite data sets we've used mainly just to kind of provide a background overview for, say, Lidar projects where we don't have any data. But, we work with imagery from planes and drones, all kinds of things. So if the request came through, we could definitely work with satellite. I think that more, Rick, the team at Quantum would work more with satellite than our Kurt and I would, though.
Yep. All right. Well, we're at past 2:30 at this point. Again, really appreciate all those that attended. Again, reach out anytime and enjoy the rest of the conference. Have a great day, everybody.